Hello and welcome to The Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. I'm Eric Markham, and today we're discussing Squid Inspired Smart Windows. In this episode, we will be discussing an innovation within window technology that was inspired by the color changing ability of cephalopods. Before we can talk about the developing technology, we need to address some background. A team of researchers from the University of Toronto have been hard at work applying biomimicry, which is a practice where engineers draw solutions from nature in order to create a changing window pane, much like how a squid would change its skin. Cephalopods have two main biological systems that are responsible for altering their pigmentation. The first is a specialized cell called a chromatophore, which is basically a pigment filled sac that can mechanically actuate to change how light refracts, which gives them the ability to shift colors. The second mechanism is a layer of iridophores, which sit deeper in the skin and controls how light is reflected. This ability to change how light behaves addresses one of the most critical issues with energy consumption: heating and cooling. Nearly 20 to 30% of energy consumption is due to heating and cooling a house. Specifically in the summer, power grids can see a significant draw in the electricity for AC units in residential, commercial, and industrial areas. While the outside temperature will raise a home's temperature, 70 to 75% of the heat coming into the home is through the window. Solar energy is comprised of two wavelengths, light and infrared. Light is the most obvious, as it is the only one of the two that remains on the visible spectrum. Infrared, which we can consider heat, is not visible to the human eye. The second wavelength is responsible for the heat entering your home. That's where the developing project comes in, a sheet that can change how light is introduced into your home. The current prototype is a 30 by 30 centimeter triple layered plexiglass sheet, with each sheet having patterned grooves carved within them. Each of these layers are filled with three different liquids, mirroring how chromatophores and iridophores are on a squid skin. The first layer is filled with a water-based dye solution, or glycerol, which is responsible for absorbing light of various colors. The second layer is filled with a carbon pigment suspension that can control light transmissions. The third and final layer is filled with titanium nanoparticle suspension, which directs light that passes through it. The idea behind the design is that by combining varying amounts of liquid in each layer, you can make the window more efficient. For example, you may not mind all of the light and heat coming into your home during the winter, but what about the summer? You either must let both wavelengths into your house for light, thus adding heat to the already warm house, or shut the heat and light out, forcing you to use electronic lighting. With the squid window, you could allow the light to enter the room and reflect the infrared, keeping the heat out while naturally lighting your house. With just one layer dedicated to blocking the infrared light, researchers were able to see that the window could save up to 25% annually on heating, cooling, and lighting energy. Add the ability to change how light is dispersed into your home, and the savings double to 50% annually. Compared to previously existing darkening windows, these liquid windows are capable of saving 75% on heat energy, 20% on lighting, and a whopping 43% on the total energy used. These are significant savings for what is essentially a plastic sheet filled with water that can be placed over an already existing infrastructure. The researchers are still hard at work, figuring out how they can produce these screens on a large scale and integrate them with existing architecture. One area of growth the team is interested in is incorporating an AI to analyze and control how much liquid should be pumped given any situation. This AI would be able to make automatic micro adjustments to better optimize the window. It's incredible to think that we're able to solve modern technological issues by drawing inspiration from an animal that has existed for 100 million years. I hope this opens up your mind to look deeper into the mundane to produce the extraordinary. Thanks for listening.